more. A lot. Okay, so let's. Isn't that chapter 7?
No, it's just chapter 7.
That's number 3, Lauren.
So differential equations.
So you're recording.
Please
So
start.
6.1, we go back because some of the rules where we had substitution required are in this lesson. So for whatever reason the book did, I think the book does it out of order, but you need to use substitution, and I wrote that in your lesson plan, that you need to use substitution for some of the problems. You will see that most of the stuff we've actually learned all the skills for already. It's just a different type of wording. So differential equations. We've learned, do you remember when I say a differential is like dx or dy, right? Not dy dx like we have here. So when we have a differential equation, it's when we separate the dx from the dy. So I start out with dy over dx equals secant squared x plus 2x plus 5. So what I need to do, think of this as if we're going to multiply both sides by dx. So we have dy is equal to this whole thing on the right side, secant squared plus 2x plus 5, and then a dx after. So what we're trying to do here, let's find all functions y. That means we want to get y equals something.
Oh.
I don't know. Went here. So y equals some equation. Now, in this equation, we don't have, this is basically where we're going to use the integral, because I want to get rid of the dy and dx. The only way I can get rid of it is to take the antiderivative of both sides. I'm going to take the antiderivative and put it in front.
And that's the only way.
Yeah, the only way I can get rid of the dy and the dx is to integrate. Okay, so on the left side, think of that as just being a 1 dy. So you get y. I'm going to put a plus c1 because we're actually going to end up with a c on both sides of the equation. Notice that I don't have any bounds here, so I have a y plus c here. On the right side, the antiderivative for secant squared. And then this would be 2x squared over 2. So that just becomes x squared plus 5. And then a plus c. I'm going to just... Oh, yeah, sorry. Yeah, so they're not the same c. So when we do this, I usually only like to add c to one side. Remember, I'm trying to solve for y, so I usually don't even add a c1 here. I just add a c on the right side. So basically you end up with x plus x squared plus 5x plus c.
I can get rid of the C on the right.
Okay, so I can't get rid of the c on the right because
I mean the C on the left.
technically when you take the antiderivative without bounds, you automatically get a plus c. So you get a plus c on this side and a plus c on this side. So I would just combine like terms, subtract c1 from both sides. So if I have a constant and I subtract another constant, I'm still going to have a constant. I never write out the c1 and the c2. So just so you know, I automatically put the plus c on the side of the x.
So you just need to know to put.
You just
plus
need to
C
put
there.
a c on one side. You don't have to put it on both.
That's it.
That's it. That's it. Now, right. So we're always solving. So in this lesson, we're going to have a general solution. Anytime you see the word general solution, that's going to be a y equals something, and then a plus c. So when I first showed you these indefinite integrals, or well, why do we need the c? After we do these examples, we're going to have a particular solution. So we actually have to figure out what that c is equal to. This is a general solution, so it's not exact because we don't have enough information to find out what c is equal to, but Later on we will.
So an example one also be a general solution.
This is a general solution. It's just so we're doing the exact same thing for these. I just use different wording. So find all functions y. That is the general solution. It's the same thing. Okay, so the first thing we want to do is separate secant x tangent x e to the x. So the first thing we do is separate the dx from the dy. And then what was the next step? Antiderivative. This is really like step by step. Move the dx over, take the integral. On the left side, we'll always just get y. It would be y plus c, but remember, I'm just automatically going to add the c to the right
Is
side.
secant x tan x just secant?
Just
Secant
secant.
squared.
No, just secant.
Um,
And then, but yeah.
If we don't have to do the first part and we automatically know the second, like, I didn't have to do 2 steps. If we did that on the test or quiz, like, is that fine
I suppose
in a
so.
sense? Just wondering.
If you went straight to y,
Okay, so there's a reason why I am doing it step by step. When you have okay, there's a time when you can't just go to y because maybe you have an equation with x and y like multiplied together, for example.
Yeah.
So
So
something
like-
with implicit differentiation. That's kind of why I'm showing you step by step now, because there's going to be a time when you can't just go to y. Here, yes, I see what you're saying. You can just go to y equals and then the plus c. And I guess, to be honest, I'm okay with that. I'm okay with that. Here, this one, again, I'm going to rewrite this as x to the negative 1, x to the negative 2, dx. So now when I take the antiderivative, end up with y equals, so x to the negative 1, that is our rule that doesn't work. Well, it would be, so if we try to do x to the 0 over 0, we get something that doesn't make sense.
yeah.
So that's our one,
Uh-huh.
that's our one that doesn't follow.
I wish I knew that.
Plus 1 over x.
Plus 1 over x, because it's x to the negative 1. And actually, we don't need our absolute value because we were given in the very beginning that x was greater than 0. If they didn't tell us x was greater than 0, then you would need to have the absolute value lines in there.
So,
But that's all we
just
can
if
do.
one happens, should we leave it? For instance, like, would you take off points if you-
No, I wouldn't take off points, but. All right, this one. So this one, we can go to separate the dy and the d. This time it's a dt. But this actually looks like.
We have to substitute.
So when we go to take the antiderivative, yeah, I'm going to do the integral sign first. And then I'm going to say, let's let u equal what? Sine t. So this means du is cosine t dt.
Oh, and we have that.
And we have a cosine t and a dt, so that's going to be replaced with just du.
Is there any
Derivative. Remember, du is the derivative of sine. So derivative of sine is cosine dt.
And we're taking a sign difference.
So from here to here, I'll have y equals, I haven't done anything, I haven't integrated. I'm just replacing, the only thing I've integrated is the left side, that's fine. The antiderivative of dy is just y.
How did you see that you made
Well, because I have a composition of functions. And product. And I don't have a, this is going to be what? Which ends up being e to the u plus c. So y equals e to the sine t plus c. So we've pretty much done, these types of problems, just not, they don't look exactly like this and we haven't given them names. So when I say a differential equation, That means that, or to solve a differential equation, it means starting with the derivative, separating the dy dx, and take the integral. Okay.
How come for the other ones we didn't have to use U, and for these we could
Because they're composites.
What?
They're composites.
Composition of homogeneous. When you have a composition like
Which you think
e
would
to the
multiply
2x.
together.
Cosine times
Okay.
B.
Yeah, you got,
So we're gonna, oh, no, my two steps.
Secant tangent is a
is a,
the
yeah, because the antiderivative for secant tangent is just secant.
Yeah.
David is worried that he's gonna miss information because he solved it, so he wants to get it inside.
Okay.
But the thing is, he would miss it anyway.
I have to go, yeah, so I'm just reading. Okay, so now we want to look at what happens if we have enough information and we can actually figure out what C is equal to. So that's when we solve an initial value problem. So far we've had plus C.
Isn't that just bounds?
Well, this is a little, it's not just the bounds. It's a little, it's not that complicated, but we're looking for an exact equation where here's so this is the derivative and it goes through a particular point. Okay, so for example, just over on the side. You guys, we've talked about, for example, if I said dy dx is equal to 2x, what would y be? What's the antiderivative?
It's
X
X
to the
squared.
x squared plus c. So that means x squared plus c could be any number of these graphs, right?
Okay.
So what I'm telling you in the next set of problems is, okay, well, it goes through the point 0, 0. So that means it can't be this graph, it can't be this one. It's this exact solution. We have C. We have enough information to find out what C is equal to. That's what we're doing in these. So it's going to start out exactly the same. Right. So I'm going to start out the same way. Here's dy dx is e to the x minus x squared. So I'm going to separate and so I get y equals, oops. No, there's no U substitution. There are a couple problems on homework where you run into U substitution. So most of them are not. Most of them are just, and most of the ones I will give you on the test will not be U substitution. In fact, I don't think I give you any U substitution with these on the test. I'll double check. What's the antiderivative for e to the x? And this one will be minus x to the third over 3 minus 2x. Okay, so think of this, all of this.
Substituting x and y.
That's like step 1. Okay, so step 2. So step 1 is solve for y equals, you know, or the y equals question mark. That's like the first step. So it looks exactly like the ones we had done on the previous page. Step 2, plug in x, y, and solve for c. So I have 1, 0. So I have 0 equals e to the first plus c.
So just plug it in.
Yeah, just plug it. So in order to solve an initial value problem or find a particular solution, you have to have a point. So x is 1 and y is 0. Substitute all of that in and solve for c. Now, I end up with e minus 2 plus c.
Yes.
So,
1.7.
well, okay, but don't, here's where I want you to write exact. So if this is e minus 2 here, then 2 minus e would be my value for c.
It's negative.
Again, don't give me a decimal approximation, just leave it as 2 minus e. I want things, because we're looking for the exact solution. So then step 3, plug c back in. So it's y equals e to the x minus 2x to the third plus 2 minus e. And that's the final answer. So it's kind of nice. I mean, it just follows those three steps. So you're going to solve for y with the plus c, plug in, find out what c equals, and then just rewrite the equation with c in it. Are we okay with that one? Do I scroll down? You want to try the next one on your own? Oh, that's not so bad. Thanks.
I know there's like
It's been a long day.
No,
Come on,
I-
somebody give it a
I
try.
haven't had a break out there. I haven't had a break at all. Throughout. I haven't had a bonus or a And then I have to stay here until 5:30.
Okay, I don't have to do that. You want to come up? As soon as she's done. Tablet or the board? I never have much luck with the board, but you can, or the tablet. It's the same one.
Oh, it's so much easier than
I'll do it.
On the board? On the board?
I'll do it on the board. Actually, tablet.
Minus C.
No. Plus 2 minus e. Back in. What is c?
How do you like scroll down?
I just use the mouse.
Oh,
Yeah,
okay.
I just do that. Okay. So the first thing we're going to do is separate the dx from the dA.
Okay.
Now, I wrote out a equals 6 when x equals 1. It's the same thing. I'm just plugging everything back in. Now, c, 0 equals e minus 2 plus c. So if I'm solving for c, everything needs to move to the other side.
That's why the writing is like that. I looked up and I didn't know he was doing a problem, and I'm like, oh, wait. Oh, okay.
I did. Yeah. Mine's 14.
That's not good.
I got plus 1.
Oh, I didn't have your.
Okay, and then you
Is it saying 1 out of 10, 5?
I just didn't.
So you guys should find more.
Okay, so that, what row we put up here, that's for the first part. 10.
Oh, now I'm going on to the second part.
Now, plugging in a equals 6 when, so it's like, the second part is plugging everything in.
Wait, I got one. But -1 squared is positive. That's so confusing. I don't understand
2
that
minus
stuff.
1,
How do you know like
1, 5.
Yeah, it's a little bit.
Good, so we get c equals 1.
Yeah.
Except the
Did you
next
get
one.
one?
is fine.
All of these to the 10s to the 5th, those are all 1 plus 1 minus 1. And then just make that equal to a. Let's say plus 1, plus, wait a minute. No, wait, erase that.
Erase it? Okay.
Don't look at it.
No, up top row.
Up the top row?
No, yes, the top.
Everything.
Yes. So
Okay.
from here, from step 1.
From
You're
s-
basically taking step 1. So once you've integrated, you're done with this. So just, it's A equals this line, and then you just plug in what C is equal to. So it's A equals.
Oh, right, I
Remember
forgot.
that it's the, you're putting in the solution, so you want the A equals or usually
Oh.
Y equals.
How does 6 equal?
6 is, A is 6, so we substitute when x equals 1.
Oh, I forgot plus C.
Plus 4x and then plus 1. There you go. Okay, good.
Tan of 0 is 0.
Yeah. You guys get it? The next one, we didn't like the next one. Did anybody try it?
I did. Wait, I think I got it.
C is 3. I try it. C is 3.
Oh, well, but it's tension over here.
I know, especially, oh no,
Is that right?
I have it. Okay, it looks worse. It's not really that bad, guys.
You have to do wait, is C3
Wait, it gives you product
We
rule?
won't know in 5 seconds.
part of a million?
So when I take the antiderivative,
5 tan x.
okay, so the 5, remember the coefficient for the 5 just stays with the tangent. Now this becomes x to the 3 halves over 3 halves. So what happens to the 3 halves?
Minus x to the 3, so it's just minus x to the 3 halves.
Well, the 3 halves are going to cancel. Do you want me to
Well,
show? No, it's just going to be. So right here, right, these two are going to cancel. So I have 5 tangent x minus x to the 3 halves. Let's see. So now I'm going to plug in y equals 3 when x equals 0. Well, what's tangent of 0? 0 to the 3 halves. So c is 3. So now, plug it back in. So it's y equals 5 tangent x to the 3 halves plus c, or plus 3.
The next one is really easy, right?
Did I even give another one?
Yeah.
Oh,
The
should we just do it?
You just said that it looks complicated.
You get c equals 1.
Like the most roundabout way. Yeah.
Sine of C.
C equals 1.
Sine is
Is it positive or negative? Yeah. It's negative. Pretty sure it's negative because you're doing antiderivative, not the derivative.
It's 1 equals sin x plus 1, right?
Pretty sure it's
What's the derivative of sine?
Oh no, maybe you are right.
Wait,
Are,
sine
are
of
we
C-
having an issue with the positive or the negative?
Wait, is sine higher or sine lower?
I'm pretty sure it's positive.
Okay,
Is sine
the antiderivative for cosine
Oh, it's negative
Is-
sign.
no, it's not.
For cosine is negative sign.
No, it's
derivative
sine.
or antiderivative?
Anti.
No.
Anti-sine.
Anti.
No.
Anti is negative sign.
No, because the derivative of sine equals positive cosine.
Is it wrong on that? Okay.
Yeah.
Wait,
That's why
wait.
my quiz was wrong then.
Wait, so
Blame it on the quiz.
the derivative.
It would be blame it on the calculator, actually.
Blame it on the quiz.
Wait, Miss Mason.
Wait, but
These
Here.
are supposed to be the antiderivatives,
Sine
right?
of 0.
No, those are
is
derivatives.
So then that's why my whole quiz is wrong.
it's sine of
Yeah,
zero. It's sine of
Right here, guys.
Yeah.
Antiderivative.
Sine of 0. Oh,
Sine of 0
Antiderivative for cosine
Wait, is that
is a
wrong?
positive sign.
And that derivative for
Sine is negative cosine. See, sometimes it pays just to memorize it. So it's positive sign.
Too long. It's
No,
one-
because I just trusted my calculator.
Well, what if,
Okay.
what if?
Any questions on these so far? Is the next part?
No curve?
Wait, no.
No?
Let's go on to slope fields. We're ready.
wow, you say so.
Yeah, the slope fields are,
This looks fun.
Easy, hard?
it actually is, no, they're really pretty.
It looks
Then
fun.
let's go. We
The
only
only
have
thing-
15 minutes.
So slope,
You gonna miss the event?
is rise over run.
I have allergies.
Are you sure that's the best way to do
Okay.
Can you go back up?
Look it out, look it out.
it? And it's
I need
very
to And Lauren's even more
Of what?
Just yes, David.
dark. Please continue.
Let's go.
She's noticing our personal
Honey, you have door
problems.
closing problems.
You keep like a camera on your face at all times. Just like get your facial expression.
Just my facial
They're
expressions.
priceless.
Glad you find my facial expressions entertaining.
Miss Gazer, if you think that you're being nice by not saying anything bad.
But your facial
But your
expressions say it
face-
all.
It just gives it away.
They say it
It's
all.
true. It's true. I just
Because they say everything that you're thinking also.
not always.
Slow food.
Can we move on?
Yeah.
Slope fields. So slope fields are pretty easy as long as you're good with estimating what different slopes would be. For example, oh no.
So for not good at that one,
Like a positive slope, like positive slopes
Go up.
go up.
Oh, I can do that.
Negative slope goes down. Okay. Now, a slope of 0 is a horizontal line. And if it's undefined, we don't have to draw anything. It's a vertical line, but we usually leave those 1. Okay, so you have a set of 12 points here, and at each particular point that's on the graph, we want to find the slope. So remember, dy dx represents the slope of the tangent. So for example, dy dx, let's say let's go with 1 comma 1, would be 1 over 1. I'm just basically plugging in. So over here, at 1 comma 1, the slope is 1. So what we're going to do is we're going to make a real small segment, okay, and just make it look like a slope of 1. What's the slope of 1 look like? It's an equal amount of rise over run. So maybe like here. Okay.
So just through it?
Yeah, just through the point. So through the point, we're just going to go like that.
Oh, we're not connecting.
Wait, why do you
How do you get the one
Oh,
for
is that
one?
one? No, one.
But at y equals 0, it's undefined, so does that mean
Alright,
it doesn't
so
exist there?
So at 1 comma 1, our slope is 1.
Where do you get one? Oh, it's line.
This is the point 1 comma 1. Okay, so this is the point 1 comma 2. So dy dx, you don't have to write this all out, but the dy dx at 1 comma 2 would be 1/2. So a
It's also
slope of
positive,
1/2 is
isn't it?
also positive, but it's not going to be this. It's going to be more horizontal. A slope of 1/2 would be like up 1 to the right 2. Oops. So it's going to be a little less steep.
I don't know if I need it.
It's okay as long as it's just a little less steep than the one below it.
How
How
do
do
you
we
know
know
it
that?
exists there?
Okay,
Just keep going.
because this is just this is just one of those things. It's like algebra 1 in terms of slope is rise over run. So if you have a slope of 1, then the amount of rise to the run, it's hard to do dotted lines on here, is about the same. Okay, so this would be like up 1 to the right 1. You're making just little line segments, so you can't really just count because there's no graph, there's no grid lines to really check. It's just kind of eyeballing it, and you just kind of look and estimate. It's not going to be exact. Okay, so the next one is 1 over 2. So that means like this distance here should be like half of how far you go. I think the battery's going a little. Do you see this? So this is like 1, this is over 2. So you see how I got I don't like.
Do it for all the slopes.
Yeah, but you'll find out some of them are really easy. Like this, let me just redraw this. What happens, let me go over here to negative 1, 1. So that's going to be negative 1 over positive 1. Slope of negative 1. Yeah, it's just the opposite direction. And then here, this one, negative 1 comma 2,
It's the same thing as opposite.
it's going to be negative 1 half. So it's going to be a little less steep, but still a negative slope.
Do you have to do all the points?
Yeah, we have to do all the points. Now, here's where it gets real easy. Anything on the x-axis is going to be a 0. Think about it. 0 comma 2. 0 over 2 is 0. So it's going to go straight across. Next one, 0 comma 1. So it's going to be 0 over 1. So it's a little horizontal line. All of the ones on the y-axis would have a 0 in the denominator.
Wait, you flip
So you don't even do
So
anything.
you don't even, you leave that blank.
You mean the x-axis?
Oh, I'm sorry, did I say y-axis? Anything on the x-axis, because the y-coordinate would be 0, it would be undefined. If you want, you can put little vertical lines, but usually we just leave those blank. I wouldn't mark you down if you put a vertical line. And then here, what happens if you have negative 1 over negative 1? Positive 1. So this should look the same as the one at 1, 1. This one ends up being 0. Oops. Pretend I went through the point. And this one ends up being 1 over negative 1, so that looks the same as the one over here.
This is fun.
And that's your slope field.
It
Can
kind
you
of
check this on
feels
the calculator?
just very tedious. Like, I don't see the
Yeah, can I see this one?
like with everything else we're learning. Like this is just different.
It is different.
Can you check it on the calculator?
This goes, yeah, you can check these on your calculator. So you have a program called, but you're going to see it's, the viewing window is really different. So I will show you how you can check this. If you go to your programs, I gave you, which one is yours? Does yours have the E in it or not?
No,
No
it's
E.
an SLP.
Okay, so if you press slope field and press enter,
Oh,
it's gonna,
Just slow, look what happened to mine.
You just press enter again.
Press enter.
input.
okay, so input dy dx.
You do x.
So you're gonna do x divided by, so it's asking
Wait.
for a y. Alright, I'll have to check. So you see down here above number 1, you have a green y. So I'm gonna press the alpha button, alpha, y, and that will get me my y variable. Press
Oh
enter.
my god, this is so weird.
And let's say you wanna view the slope field, so that's number 4.
This is really cool.
And there it is. Now it's going to graph it from like negative 4 to 4. But you see,
This is like
Yeah.
flipping.
But that's not what we have at 0.
So what happens?
so they're okay. So the calculator is approximating really close to 0, so it's not going to give you. It's not going to give you exact, but you see all the little horizontal, and then you see how the higher you get, the less steep your slopes would get. So that's how you can kind of compare, especially on
The next one's really weird.
The next one's a
Next
little
one is
different.
different.
Yeah. Cause like
This
it's
one?
not like a pattern like the one.
No, it's not. It's x. It's just x plus y. So you would just like plug in.
It's just like a bunch of random lines going in different directions.
So like dy dx at so like at 0, 0 would be equal to 0. So you just draw a line here. So here you're just adding the coordinates. So like at 0, 1, it would have a slope of 1. At 0, 2, it would have a slope of 2, so it's going to get steeper. Like up 1 over, or up 2 over 1. What's it going to look like at negative 1? 0 plus negative 1?
It's gonna be negative.
Negative 1, like that. One of the things with the slope fields is don't let them, they should be separate, so you don't want to make them too close together that they're intersecting.
This is too small.
No, it's okay. So 1 comma 1, this is a slope of 2, so it should look like this one. If it's not exactly a slope of 2, it's fine. Just, you should be comparing to what you have on your own graph. So then what happens at 1, 2, you get a slope of 3. So this should be even steeper than the last one. That's kind of the approach you want to use.
What are we doing tomorrow? We should do
We're gonna review this lesson.
We're almost done.
Yep.
We're done with this lesson. That we're gonna do next week.
We have one more lesson.
So this is
Is there
0.
a chance I could ask you some essays questions?
Today or tomorrow? You're taking the SAT this weekend, so.
You don't suck.
My mom called and she's like, you know they're changing the SAT. I'm like, I don't really care.
You're done taking it.
I know, but
Making
making
it
the
so
vocab
much
easier.
Why?
Getting rid of
I
all
don't-
the D's and going vocab and only using the
Why is that
vocabulary
one
that'll be
straight and
used
that
in,
one
like,
curved?
college courses
That's
and
supposed to be
stuff.
straight.
That's not fair.
It's no longer.
That's supposed to- -1 plus 1 is 0.
Section is only optional.
Why is it not
Of course it's fair. This is
normal?
so much better for us. Scores are gonna skyrocket. There's gonna be a
-1 plus
higher bell
-1 is
curve.
-2.
And it's gonna take an even more perfect score to get in. Right
You're
now that
plugging-
it's more challenging, we're higher scores than the average, and then put us at a higher payment.